I got interrupted. Someone broke into my garage over the weekend, and that was the Minneapolis police calling me back. Don't break into people's stuff. It's just mean. It's like really mean. Please don't do that. If you need something, just knock on my door and ask. Seriously. Okay. We had gone through this one. 3 times 7 is what 21 is, and we talked about the rule of divisibility rules. Divisible. And I said the sum is to add. Divisible means, I'm going to have a sheet of vocab. Divisible means that something can be divided, a number can be divided by that number and still get another natural number. So we're going to talk about some divisibility rules. I think I'll just put it on a worksheet and give it to you guys. But because this ends in a 0, we know it's divisible by 10. This is 6 tens. We know that because it's in the tens place. So I could say 6 times 10 because that's a factor pair, and then splice that out, and we'll get there. But I also wanted to do this divisibility rule we talked about with 3s, where if you sum the digits and it's divisible by 3, or it's a multiple of 3, then the whole thing is divisible by 3. So 6 plus 0 is 6. Is 6 a multiple of 3? Yes, it is. It's 3 times what? If I divided this by 3, 20. So I can do this. 3 is prime. 20 is not. 20 is how many? 2 tens. It also ends in 0, so we know it's 2 tens. So I get to 5, or 10. 10 is a good one to just memorize, right? If you divide it by 2, which you can, what do you get? There's a reason. 10, 5 each. 5 is prime. So 60 is 2 times 2 times 3 times 5. That's the unique prime factor. I better write it down here, right? No matter what order you do this, it's going to be 60. Gosh, that's slanty. It didn't make it much better. It doesn't look slanty when I'm staring at it this way. And then when I stare at it in there, it's like slanty. So 2 times 3 is 6. 2 times 5 is 10. 6 times 10 is 60. 2 times 2 is 4. 3 times 5 is 15. 4 times 15 is 60. And we talked about briefly about the clock, which I need a battery for. It was clicking. And now there's something else buzzing. So that's 60. Well, 60 ended in a 0, but let's look at 381. Okay? And you're going to miss me because I'm going to do my dip-de-doo. Ready? Dip-de-doo, I miss you. Okay. So, 381. Let's talk about our divisibility rules. Let's just see, because this is a mess of a number. It ends in an odd number, which means we cannot divide it by 2. Okay? So can we divide it by 3? In fact, we not only can't divide it by 2, we can't divide it by any even number. And we know that 5, every multiple of 5 ends in what? 5 or 0, right? 5, 10, 15, 20, 25, 30. I remember counting by 5 as a kid. It was the best. Skip counting, right? So this ends in a 1. So we have to look to other odd numbers. So is it divisible by 3? Well, let's add this up. 3 plus 8, can we do that in our head, is 11. 11 plus 1 is 12. Is 12 divisible, a multiple of 3? Question mark. And the answer is yes, okay? So that means this number can be divided by 3. It can be. I know that. Well, when I divide it by 3, what do I get? I'm going to let you guys off the hook on this one because we're not going to do long division right now. But this becomes, I believe, 127. Does it become 127? You guys tell me. Now, once again, this is an odd number. No fun. So, can this be divided by 3? Well, 1 plus 2 is 3. 3 plus 7 is 10. Is 10 divisible by 3? And the answer is, for this one, no. Is it? So we can't divide it by 3. We can't divide it by 5. We can't divide it by 7. I actually know this because if this divides by 7, this has to, and it doesn't. 12 divided by 7 doesn't work. So we're going to have to keep creeping up with our primes. So I, myself, am going to see if I can find a prime. Now, when you look for a prime like this, you only have to go halfway. And what I mean by that is, remember when we talked about our factor pairs? As long as you go up, you can go back down. I made these numbers right out of the clear blue sky. All right. 127 divided by, let's go to the next prime, 11. Nope. Right? 127 divided by 13. Nope. First of all, I'm going to make sure my 381 divided by 3 is correct. Yeah, 127. How about, what's the next prime up from 13? 17. Nope. 127 divided by, what's the next prime up from 17? 19. Nope. 127 divided by, what's the next prime up from 19? Is it 21? No, it's not. We did that already right here. We know 21 has factors. So it's 23. The number 23. Nope. And you know what's happening? You want to look at my calculator? What number do I have here now? 5. I have gone more than halfway. That's what I mean by that. Actually, anything over 11, because 11 times 11 is 121. So I know that 127 is, what's the word when it can't be divided evenly by anything but itself? Prime. 127 is prime. It gets circled. Done. That's it. So this number was significantly larger than this number, and it's larger than this one, right? But this only has 2 factors. So does this. This one has many. 1, 2, 3, 4. And in fact, you can bibbidi-bobbidi-doo with all that. Someone asked me about a sandwich board like a couple of weeks ago. My sandwich board would have math on it. So these are prime factors. These are what people call factor trees because they look like little trees, except for they're not. They're like the roots, except for those aren't. I mean, see, vocab matters. All right, this is the last thing and for today, and then I'm going to have a list of vocab, I think. Vocab. All right, hasta luego. Happy coffee. See you later. Stay safe. Stay comfortable. If you can go for a walk, do it. It seems like it's a lot colder today in Minneapolis anyway. Stay safe wherever you are.